Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. So today we're going to be starting the series on how to solve trigonometric functions using quotient rule. So as you can see, the first thing we have is the question f of x equals sin x over cosine x, and we are to find the derivative of this question. So the first thing you notice is that we have the function, and this function is comprised of two subfunctions that are one subfunction divided by another subfunction. So the first subfunction at the top, the numerator subfunction, we're going to compare it to the general equation. So we have a general equation, first of all, on the left hand side, which is f of x divided by g of x. We have our actual question, sin x divided by cosine x. When we compare both equations together, we can therefore write that f of x equals sin x and g of x equals cosine of x. And that's how you do it. Like, that's the first information. So now that we're done identifying what f of x is and what g of x is in our question, we're going to go back to what we're supposed to do. What are we supposed to do? We're supposed to differentiate this function. So as you can see, we have the first equals sin x, and the denominator subfunction, which is the second subfunction, equals to cosine x. And when we have that, we basically that's what we do. So now the next thing we have to do is, since we're asked to differentiate the function sin x divided by cosine x, we have to think about a rule that we can apply to it in order for us to properly differentiate it. Since our function involves two subfunctions that are related by division, we have to apply the quotient rule. And the general formula for the quotient rule is the derivative of the numerator subfunction f of x multiplied by the denominator subfunction g of x minus the derivative of g of x, which is the denominator subfunction, multiplied by the numerator subfunction, which is f of x. All of that information divided by the square of the denominator subfunction. So that's basically what we have, right, so far. So now that we have this information down and clear, we can start applying the quotient rule to our question. So we have here the derivative of sin x divided by cosine x, right? So in order for us to do that, we can start by, what is the derivative of the first subfunction, f of x, which if you look at the top of the screen to our right, we have it in a red box, the derivative of f of x here. So we're going to put a sin x here. So that's the derivative of sin x, right? Multiplied by just g of x by itself, multiplied by cosine of x, right? Minus the derivative of the second subfunction, g of x, so the derivative of cosine of x, right? Multiplied by f of x, which is sin x. All of that divided by g of x. So what is g of x? Cosine x. And then we put a squared. So that's it. So now, we're gonna start applying derivatives. So what is the derivative of sin x? Well, we do not know what that is. So we're going to go into our trig notes. So for those of you who have watched my series on chain rule as well as product rule, you already know I always have the trig notes anytime we're dealing with trigonometric functions on my videos. On the left hand side, we have the trig expression, which is everything in blue. This just involves how one trigonometric function, such as sin x, relates to another trigonometric function. So sin x and cosecant x are related in terms of reciprocality, just like cosine x and secant x are related as a result of reciprocality, as well as tan x and cotangent x are related due to reciprocality. So they are basically reciprocal. So cosecant x and sin x are basically reciprocals of one another. So those are trig expressions, how trig functions relate to one another. Then on the right hand side at the top, we have what we call trig identities. From my understanding so far, I understand trig identities to involve trig of how trig functions that have squares relate to one another. So how cotangent square x relate to cosecant square x. And this is the equation that we basically use to relate them to one another. And again, as we go through this series, we're going to always have these notes. There are going to be 30 episodes in this series, hence 30 different questions, because there are 30 different ways for us to permutate this question and arrange them. So therefore, we have 30 episodes in this series. We're going to be using these trig notes in every single episode. So every single episode, you're going to please have that. And one thing I wanted to mention is, if this is the first series from me, please pause this video right now and write these notes down. So yeah, and then all the stuff written in red marker at the bottom is basically what you call trig derivatives, right? Trig derivatives, that is it. So now, what was our question? We had derivative of sin x. Derivative of sin x. So we know the derivative of sin x is cosine x. So I'm going to put that down here. Our answer is now going to be cosine x, right? And then we have multiplied by another cosine x, which we're going to bring down here. So multiplied by another cosine x minus, what is the derivative of cosine x? So we're going to go back. The derivative of cosine x is negative sine of x, right? Negative sine of x, that's the derivative of cosine x. So I'm going to put a negative sine of x here, right? Multiplied by sine x that we have here, right? And we do that, all of that divided by cosine x, all of that squared, right? So that's it. Yeah, that's what we have so far. So we go to the next page. We have cosine x and cosine x. I'm just rewriting what we had in the previous page so we can solve further. Cosine x, cosine x. So we have a minus here and a minus here. We can neutralize that and have a plus sine x, sine x. All of that divided by whatever g of x squared is, which is just cosine of x, everything squared. Or we can also say cosine squared of x. So we have all of this information right now. So we can have this, we can go on to write this as cosine square x, right, plus sine square x. And the reason how we do that is cosine x multiplied by cosine x is the same thing as cosine x all in brackets squared, or we can write it as cosine squared of x. So I'm going to do the squared of x instead of everything in brackets squared. So we have sine x multiplied by sine x, we have sine squared of x. All of that divided by this here, and that is cosine x, everything squared is the same thing as cosine squared of x. So that is that. And yeah, that is basically it. You can go on to see that this is what our answer would be. So when they ask you to apply quotient rule, this is literally your answer. Your answer is what we have in this black box, right? But then there is an issue, and the issue is this: anytime that you have a question that involves trig, whether it's part of the solution, the beginning of a question, you have to try your possible best to simplify as much as possible. Just like if you're given 60 over 1000, you're not going to keep putting 60 over 1000. Common sense and also experience with math will tell you that it's good for me to simplify my work. So how can I simplify this work in order to make solving easier, right? So instead of having 60 over 1000, we simplify to get 3 over 50. That's a more simplified version in comparison to 60 over 1000. So that's what we're going to do here. We're dealing with trig. Anytime you have trig, use your trig notes and try your possible best to simplify the question as much as possible. So now let's go to the trig notes because we need to use it to simplify. We have cosine squared of x, right, plus sine squared of x, right? You can go ahead to call this. So let's see here. So we have cosine, we have this, where we have cosine squared of x plus sine squared of x. What can we compare? If we look at the trig expression, we have this, we have this. So like, what can we do? Well, what I'll just say is, remember what we have is cosine squared of x plus sine squared of x. Guess what? Cosine squared of x and sine squared of x is the same, cosine squared of x plus sine squared of x is the same thing as sine squared of x plus cosine squared of x. So what what does that equal? It is sine squared of x plus cosine squared of x. What does it equal? It equals to 1. So we're going to have that. We rewrite this here, cosine squared of x plus sine squared of x equals cosine squared of x. It's the same thing as having 1 over cosine squared of x. So hence, this is a breakdown of the answer. Now we can go to our previous page and see, is there a way for us to break this 1 over cosine squared of x? Is there a way for us to break it further? Well, in order for us to solve this and answer the question, let's go to our trig notes to see. Well, when we look at reciprocals, so we look at the trig expression part of the trig notes, we see that cosine x is the same thing as 1 over secant x, the same way secant x is the same thing as 1 over cosine x. So since we have that, 1 over cosine x is the same thing as secant x. Well, now we have 1 over cosine x 2 times. So therefore, 1 over cosine x, right, multiplied by 1 over cosine x is what we have. Well, we can do the mathematics stuff. We can just say secant x, right, multiplied by secant x. So therefore, the derivative of everything we have right here, right, derivative of sine x divided by cosine x, that is going to be the same thing as secant squared of x. So this is our answer. This is literally our answer. So all of that work that we did, rather than having our answer looking like this, cosine squared x plus sine squared x divided by cosine squared x, that answer is good. This answer here is also good, but this answer is best because we did what is mathematically exciting, which is simplification and making our work much neater. So now, I want to teach you guys a shortcut method. So shortcut method basically involves this is a shortcut method. The shortcut method basically involves, at least for those of you who have watched my product rule series, this is not going to come so strange to you. Whenever I do shortcut method, it involves simplifying the function and then differentiating the simplified version of the function. So we have sine x, right, divided by cosine of x. And we're supposed to find the derivative of this. So I'm basically trying to solve what we had at the beginning, but in a faster way. Well, if you're in an exam and this is a multiple choice question, rather than doing the entire quotient rule, what is sine x, what is cosine x? Well, looking at shortcut method, sine x over cosine x, and looking at the trig expression part, we see that the trig notes show that tan x is the same thing as 1 over cotangent x, the same thing as sine x over cosine x. So we can change it and say sine x over cosine x is the same thing as tan x. So we can go on to do the derivative, right, of tan x. And what is the derivative of tan x? Let's go back to our trig notes. We see that the derivative of tan x is secant squared x. So therefore, our answer here is secant squared x. Does this match the answer from the previous page? Yes. Yes. So hence, our shortcut method and our actual method is correct. And this is a simple and quick way of doing math where you do not have to be under the stress of consistent solving. So if you're in a multiple choice exam, easy peasy, you're done. So that's it. I hope you guys learned from this video. My goal is for you guys to learn. Make sure you watch the next video. The next video is gonna involve cosine x divided by sin x, and I'm excited to see you on the next one. Make sure you take very good care of yourself, and Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.